That's what's happening here. But what's happening overall? We're breaking nucleotides apart. That's all we're doing. So this enzyme is catalyzing the breaking down of nucleic acids. How do you think you form nucleic acids? A different enzyme did the reaction in reverse. All reactions are spontaneous and goes in either direction. Therefore, we could go this way or we could go the other way. So we're just going this way because we're breaking it apart. So the first thing that happens is we formed a fifth bond right here. Is this stable or unstable? Unstable. So the correct answer, I think it would be phosphorus forms a new bond with oxygen.
Where's an oxygen?
Keep going for helping us.
How you getting familiar with the concept? It goes, it is a very rapid pace.
So it's like, I don't know.
Remember that amino acids, that's why nucleic acids they can do two types of things.
Oh, yeah. Yeah.
Describe it?
Yeah.
Describe it. The face of, I don't know if I am. Okay, that works. Good. Me too.
Yeah, I know. For the enzyme.
No. I'm trying to draw.
There's a holiday this weekend I didn't know about until yesterday. I was so happy. Like I had it in the schedule, I forgot. And Jeff was like, "What you doing this weekend?" It's a long weekend. It was like a week before. And I was like, "Oh." And it's gonna be sunny. It's supposed to be nice for
actually is at night blue sky and sunny low, just because the clouds is really low. It's like anything above 200 feet is like blue sky.
Well, you said that each one is
Lee Marysville,
and for the with the oxygen or with the
So
you're like where you guys
I think it's like how they like add a structure. Cause like when like
yeah,
people
cells are most worried about.
yeah. Look, the lab though. I didn't know if that had to say and something like that. For like I feel like with this, as long as I get Alright, because ionic are two that don't want to hear about each other.
Ionic just like
I do hate yeah, I do.
I was gonna say you went really cool. I guess it's the page actually. How long is that?
Oh, fine. You guys, I am such a dumbass. Oh my gosh. Because yeah, because it's the hydrogen and the oxygen.
Yeah, the minus and plus.
Wait, which one is polar?
Which one is polar? The oxygen is negative, hydrogen plus. Is that
Ionic bonds are polar. No, it's ionic. I was right. It's not really. It's a polar bond. No, ionic.
Let's chart. It doesn't water. Which ionic are you talking about? I thought polar converters only dealt with commercial drinking. We should know this too. No, so embarrassing.
Okay,
or maybe it's not.
I'm not doing it. I don't know. Or is that outdated? Yeah. So this is
Might actually be black. Gas lighting.
Yeah, I saw that. Yeah, why is that? And like,
Google says that's surveillance.
Yeah, I tried.
It's gotta be surveillance.
Okay,
It's surveillance. It's like a surveillance.
Wait, so like the fraud was saying like two ones that weren't.
No, two bonds that keep them like quiet and sexually attractive to the whatever thing. Like the hydrogen bond was attractive between the H and the N. And then
That's the only correct answer yet to me. Fair answer. That is the correct answer.
And then the
All right, I have a couple more questions for you.
I think it's 5.
Five is the answer.
It's 1, 2, 3, or 4.
I said 3. Yeah, I was very between 2 and 3.
Yeah, 2. 6.
The second. You know why I did biochemistry?
Oh, wait, no. No, it's 2.
Exactly. My mistake.
Really?
Feels like 40.
Two, right? Did you put 2?
This is panel 1, and this is what, panel 6?
Yeah.
So there's your monomer, there's your dimers, okay? So panel 1, panel 6. Over that, we go through the transition state. The highest, most unstable is panel 2, because we have this bond right there.
Phosphorus is making a total of 6 bonds.
And does phosphorus want to do that?
No.
We're violating what? We're violating octet. But we can violate octet. You can violate octet pretty easily with, well, okay. We're only looking at the first 2 rows because everything else is not real. That actually in physics might have made more sense. That's actually funnier in physics. Everything below the second row is not real. But because of the electronegativity, we can violate it pretty well. All right. Awesome. Keep going.
I'm on this page now.
Some people really like biochemistry.
Except for the organelle. I like it by
Oh, where you guys having that right
Well, like, so your academic history, what you're going to do is take your personal
Wait, so these only get one?
usually, or you can combine them. It is, but that's because they have 55,000 people applying.
Oh, I said donators. I'll remember I said I only form it for everybody.
For everyone, transfers even lower. It's a numbers game. No, one high school student, high school students there for 5 years, transfer, and then just give them money.
Oh, maybe it is.
The average degree plan is 4%.
Yeah. Even though it's like
First of all, what is the active site?
The active site is the enzyme
Oh, that's empty.
deconstructs, reconstructs the. It's just the part of the enzyme that interacts with the substrate.
Substrate.
I can tell you. So, I can tell you how the math works. So,
Stamps.
they accept 2,300 transfers. It sounds like a lot. Except for 1,800 of those 23 are already start students who count against the transfer cap.
We count all those first year students because we're technically going from the high school.
Correct. So, they really only accepted 500 total transfer students 2 years ago.
Wait, so like even though I had to apply like
So 2 years ago, 100%. Last year.
Yeah, we're going away.
Because like if Running Start has to apply as first year students, why would they get counted as like the transfer student thing? 'Cause, like, but it's not like AP students. So AP
No.
is stupid. I hate
AP does not count. So AP should not have credits. You should not take them.
AP.
AP
It's
does
so
not
much
have
harder.
credit.
It's so much harder.
Something
Bio.
dumb. I don't even know what it was.
So AP scores actually, so on mine, I had like 30 classes. I had like 30 credits. I had to make it because it counted as college and high school is fairly scanned.
Yeah. When I
I was so mad about that because it was like, no, it wasn't free.
No, but it is now. The year after I did Running Start, they were like, oh, it's free now if you call
It was like, what, like $400?
Yeah. So, because it's like,
Yeah, it literally is.
yeah. No, I told my friends because like they're like, oh, I was like AP.
I don't understand the question. How does the reaction rate change when the active site is changed?
So this is the reaction rate. So there's 1,000 reactions per second. This is just the enzyme as it is. This is a mutation.
Okay.
So for this mutation, This H12, his 12, is shifted up. So here it's a little bit lower here, and that changed the rate from 1,000 reactions a second to 10 reactions a second.
Uh-huh.
And
So it decreased.
yeah, so just because that one was higher, it changed the reaction rate pretty drastically. And the second mutation, the lysine, which is this one down here, changed from lysine to methionine, and that changed the reaction from 1,000 a second to 1 hour. And then in this,
Which is still decreased.
yeah, which is a lot lower. So all of these mutations are
lower.
slower. This one
Way
reaction from medium, because this one, which was part of the donating and receiving protons, can no longer donate and receive protons because it's a hydrophobic R group, because it's CH3, which doesn't participate in H bond.
Because, okay. But how does the reaction rate change when the active site is changed? It decreases?
Yeah, it decreases.
Is that what, okay. Thank you. So it would never go back to
I mean, I'm not sure if there's any mutations that would speed up the reaction, but I think it's probably pretty optimized with that setup. So I would assume any mutation slows it down.
Because these ones go round and or don't they? Like, I mean, they can have
All
more.
right, next question.
Yeah, so when this reaction is ended, this is the end, it's going to grab a new one of these and splice it again. It's going to keep doing that.
Go like this or go the way?
This one's going to leave, and a new one's going to enter.
Okay. Thank you.
So yeah, it's just going to keep going around like this. But yeah, I think if any mutation was better, it would fulfill that niche, and so that would, natural selection would probably select them to be better.
Thank you.
There's sodas we from Christie at the hospital. Like they're trying to get people like
All right.
Okay, 10 more seconds. All right, talk to your chair.
Oh, darn. Okay. I did too, but too late, I think. I'm slow to get things. Once I get it, I got it, but it takes me a while.
All right, so what's happening between 4 and 5?
This 119 gets a proton from water.
Yeah. This is giving a proton. Where did the water come from?
The water around it.
It was already there. Because water is in the environment. So do we keep track of the protons in the water? No. But that's what happened.
Water is basically the surroundings.
Closing up. Next question. Alright, closing. This is the type of results. You know what? No, we're not doing it. No, punishment. This is the type of results that hurt me deep inside. Where did the water come from?
The environment.
Why are people putting anything else?
Because what?
12% of the class chose something else.
We don't trust, I could, but
Next question. It also guarantees I know no one's actually listening.
I don't know. Is that substrate? I don't know.
Split between A and B.
Oh, you did too?
I was split between them.
Oh, could you do both?
No, I did it's a one answer one.
Oh, okay. It says multiple.
All
Oh,
right, talk to each other.
many question is when it's the Well, I did B. What did you put? Yeah. We'll see.
Water is a substrate. This is hydrolysis. So condensation reactions is where you gain water. In this one, we're going to use water, so it's a substrate. It's hydrolysis. What is the catalyst? The enzyme. Do we have any energy added to the system? No. We're not using ATP. Now, if we used ATP, we'd be adding energy to the system. We're not. So, what? Sure, but it wouldn't necessarily add energy to the reaction. So, this is a good question, actually. If you added heat to the reaction, would that be adding energy? Not really. It would be speeding up the vibratory frequencies, but we're not putting energy directly on the substrate. We're not using energy to break the bonds. Okay, cool. Keep going.
Huh? When you asked about
I put negative temperature. Oh wait, no, positive. Oh no, negative. Wait, let me recheck. So let's see, from 1 to 2, it's forming a bone, right? So that should be exothermic, because endothermic is when a bone breaks.
Yeah.
So if it's exothermic, it's negative.
I'm not sure. It's more like from first to second square, it's getting to like the most energy states. It's more unstable. I put positive, but I'm not sure.
Yeah, I like it more now.
So if it's unstable, right? Maybe.
All reactions. No, you're. It was.
When he says the second substrate, does that mean this one? Or
So this is the first substrate, and this was the second substrate. I was also confused by that.
okay. How did you figure it out?
I just read this again. So
Oh,
he was saying NAD. So this one is the
Oh.
first substrate, and the second substrate in the dotted lines.
Oh, okay, okay. I didn't get there. Sorry. I kept going back here.
Yeah, I was there for like 2 minutes. Like I don't know. Is it talking? It was like he's talking about like this.
Question? We had a controversy here. No, we were wondering, is AG going from panel 1 to 2 negative,
Is negative, yeah.
exothermic? Or?
But even though we're still forming that bond, it's still negative.
Well, because when bonds form, it's exothermic, so it's negative.
Right.
And when bonds break, it's endothermic.
Yeah, even though we did break a bond to reform another one.
Is it exothermic because it's an unstable bond?
No, but let me understand. Oh, we did break this bond here, but we made one. Oh, okay, I got you. Now I understand what he's saying.
Because this bond is so unstable, because it's now 6 oxygens to the phosphorus, it required more energy than we got back from breaking the OH bond.
Required more energy.
Yeah. Because we were breaking the octet, we had to put a lot more energy
Okay.
into forming the bond.
Okay. Oh, got it. Okay. That makes sense. Yeah, because we did break that bone. I forgot about that.
Yeah, that's why I was stuck. I was
Uh-huh.
like, we broke these small bones. That one.
Okay. That makes sense.
All right, next question. All right, talking to each other.
You put A?
Yeah, because it's asking which one is false.
Because what?
Because it's asking which is false.
Oh,
I know, I did
let's
that.
read. Jeez. I didn't read the false.
Good. Can enzymes be reused? I sure hope so. Yes. Okay. Can enzymes form hydrogen bonds? Yes. Do enzymes change? Yes. Therefore, one is false.
Oh, I didn't read false. Darn it.
Okay. I'm going to switch out this with this. What happens?
Hmm?
His 12 with that.
Reaction time is affected.
Talk to each other. What happens? What happens in the molecular level?
Well, we lost an N.
Yeah.
We gained two oxygen. We broke bones.
Well, it affects the H bond and the donation, but it still can do it. Probably just not as well.
Say that again.
So we replaced the top right one with this girl, and
The N on the top right.
I think it's. I imagine it's orientated the same.
Yeah.
It can still H bond and donate, just
What are
not
you going to
as well.
convince me to say? Something about counting carbons, right? So let's count carbons.
We almost got her.
Therefore, all this is on carbon 1. This is our R group. Is this polar or non-polar?
Non-polar.
Non-polar. What kind of interactions can I do?
Hydrophobic.
Hydrophobic. Is this one polar or non-polar?
Polar.
Polar. Therefore, this is going to be more important to the inside. We're going to change the shape of the enzyme. Is this going to be able to do the same function as this? No. Therefore, is this enzyme going to work?
No.
No, not very well, right? So, in sickle cell anemia, we did the exact same thing. We went from a polar molecule to a non-polar. And what happened? Change the shape. This one's going to do the same thing. So instead of holding these nucleotides like this, now it's going to be like that. So it's going to work worse. It's not going to work as well.
We almost got her to say it yesterday.
I know.
Did you hear about it?
We need to work on this some more.
She said she's uncorruptible.
I know. We're going to corrupt.
I think she thought about it though.
I
But
think
then
so
she said
too.
that she takes a lot of Futurama.
It's about to spill it out.
And then I was like,
But she said that when they remember.
Guys, my life.
So who ever watched it?
I've watched like a couple, like on vacation. It's
I mean, they don't get mad in the
yeah.
I'm sorry.
But then again, like kids watch like Simpsons
But she thinks
That's not much better. Like, I've heard. Oh my god.
Okay, so are you done?
Yeah.
So what do you do here? I don't understand. Canon 1 find two different types of molecular interactions.
So I found,
This is Canon 1, right?
yes, I chose,
Or is it over here? No, yeah, that's the one.
I chose each one for the first one because that's what's going to happen
So you got this one here.
messing with you are definitely.
Yeah. So I was saying it's going to,
It works.
Wait, what? Find two different types of interactions that help attract and hold the substrate in the enzyme.
so each one is going to help with these enzyme in. And then the only other one I could think of with dispersion force, just kind of like the shape of it, is going to hold the enzyme in because of how it shows like here. It's like it's going to cradle this RNA, but I wasn't super confident.
What does WT mean?
What the?
Wild type. Every mutation is
Yeah.
new allele. So before we didn't talk about what mutations were. Now we're going to start understanding at a molecular level what a mutation is. So if we have a wild type, and let's say histine 12 is our wild type, and we're going to replace it with this guy. What is this one? Serine? I don't know, whatever it is. We're going to replace it. That was a mutation. Okay, we swapped it out. Now, the wild type works on a certain function. Most of the time, the wild type works pretty darn good. But every once in a while, one might work a little better, or it might work worse. So our reactions go from really fast to slower. So if we swap this out, if the wild type reaction, what is our wild type reaction? 1,000 reactions a second, right? That's our wild type. We switch it out, and all of a sudden, now it is 1 in 10, or 10 per second. Is it still working?
Yeah.
Yeah. It's just working slower. What is 1 reaction per millennium mean?
One reaction every 1,000 years.
1 reaction per 1,000 years, so in Model 2. Talk to me about that. Is the enzyme doing anything? No. Why do we still get 1 reaction per millennium? Because all reactions are spontaneous. I have a question from this worksheet. Why do I have no dinosaur DNA? Answer that question.
Because they're extinct.
All of them, and I'm so pissed because I can't see
Well, I don't want to say 200 videos.
Because even if the DNA doesn't have the enzymes to break it apart anymore, it's still going to break apart.
I have so many things and
Return to energy.
Sounds good to
All right,
me.
why do I not have dinosaur DNA from this worksheet? Because the reaction is spontaneous to break it apart. So it's going to fall apart at a rate about 1 per millennium. Well, so if you have a mastodon DNA, why do we have mastodon DNA? Yeah, they died 3,000 years ago. So we can reassemble, we can predict based off of what it should look like, what we have. But if we had 1 per millennium and 65 million years ago, now we have
CO2.
no sequences. We have small fragments, which we do have. We have fragments of dinosaur DNA. The most I think I've ever seen was 35 base pairs or something like that. So they were able to find fossils about 35 base pairs long. And it's a fragment. That doesn't tell you anything. You need something that's thousands, millions base pairs long. Because the reactions are spontaneous, yes. That is correct. All reactions are spontaneous, therefore even fossils fall apart. Your gold rings will fall apart. Your diamonds fall apart, just slowly. Well, indefinitely only means in your lifetime, right? Or lifetimes. Yeah. Well, even resin breaks down after so many years. Right? Rock is a pretty good thing to put things in. Okay? So the wild type
Right.
is highly functional
Cement.
and then it breaks down over time. So let's keep going. Let's try to finish this up.
What type of biological mathematical second substrate? Oh, so this one. Okay. Oh, it's got that OH. Would that be? It's an aldehyde. Okay, so we have protein.
I said it was a carbohydrate, but I don't know.
Carbohydrate?
Cell force zero.
Well, probably. I think so.
Or is that an alcohol?
Huh?
Carbonated?
I don't think it knows what it's.
This is a. Yeah, it's a carbon. Carbonyl, right? Because it's it's got the H, so it's aldehyde. Wait, what H am I talking about? Yeah, it's got an H.
Yes, it's an aldehyde.
Aldehyde, right?
So that makes it.
Makes it a what? Let me ask Carter. Carter? 13. What type? This one.
So let's say.
Oh, you're not there?
I'm not there yet.
Okay, what type of macromolecule? Aldehyde. We have protein. I don't know. I think it's a carbo. I don't know. Yeah, it's a carbohydrate. Wait, because even though it's got that, but it's like a.
It would just be like a 3 carbon sugar, I think.
Yeah.
Which would just be
Because it could also be. It can't be a lipid because it's got too much. It could be a. No, because it's got an. Oh, wait. I don't know.
Would it just be a sugar that looks like this?
Yeah, I like that. That's what I think.
can't evaluate healthy students. So materials got
Oh, there are lipids with aldehydes. Oh, well, of course there are lipids with aldehydes, like there. That could be a lipid.
But I feel like lipids are,
Have more,
yeah,
more carbon,
I don't know what differentiates
more
carbohydrates.
carbonates, polar, I mean not polar. Look,
I just saw that part about
I mean, that like follows the carbohydrate ratio perfectly. Because there's 3 carbons, 6 hydrogens, 3 oxygens. So I think it's a carbohydrate. Because if the phosphate group wasn't there, it would be a So it's like,
so it looks like, yeah, it looks like a carbohydrate. Definitely. Yeah, you're right. We'll confirm, but I think you're right. Okay, so the backbone here. What's the backbone? I still don't get what's the backbone.
the backbone is the NCC. So the back.
So that's more like the main structure, main
So
bone.
primary structure. When they
The
say
backbone is like your skeleton. That's your backbone. Okay.
that's the backbone. So when we're talking about backbone groups, we're talking about the carboxyls and the NH groups, because when you have
Okay,
Carboxyls.
so the enzyme catalyzes a reaction to make things speed up. In lab tomorrow, we're going to understand how, we're going to try to understand conditions that enzymes work in. So tomorrow's lab is a really long lab, okay? Yesterday it took us the whole time plus, okay? So come ready, you know, I know, we're gonna try to get going really quick and do it. But we want to understand how enzymes work because we're going to start doing reactions starting next week. The good news is next week is what? Holiday is Monday and no lab next week, right? So we only have one class and exam next week. The exam is straightforward if you have been doing everything. What do you think is going to be on the exam? Molecules, proteins, and enzymes. That is it. Well, sugars, right? Molecules.
backbone interactions are going to be between these carboxyls and the amino groups.